This video has been prepared by EPB Center team in the context of a service contract with the European Commission. It is part of a series dealing with some basic concepts about energy performance in buildings. This one deals with some tricky things that might happen when you start considering exported energy. And you will have to make a decision about that when defining the energy performance of your building. Let's start from the beginning. This is a so-called assessment boundary, which is separating your building from the external environment. In the past, we considered energy flow only in this direction, consisting in one or several energy carriers that were supplying to the building and measured at the assessment boundary, where there is a so-called delivery point. Therefore, this was called delivered energy. When we had to sum up different energy carriers, we used to weight them by a primary energy conversion factor. Here, for example, if we need 1 kWh electricity, we take into account that in the middle between the source and the delivery point, you have the efficiency of your generation and distribution system of your grid. So a typical value is 2.5 for electricity. For each kWh delivered, you draw from the source 2.5 kWh. So the energy performance in this case is the delivered energy 1 kWh times the conversion factor 2.5. And by the way, this value might change depending on the structure of your network and particularly on the type of the generation system feeding the grid. And by the way, this 2.5 is 2.5 non-renewable because most of grid electricity in Europe is generated from fossil fuels. Nowadays, we also have the capacity of collecting and transforming energy directly on site. An example is PV panel. So if we feed our lighting with a PV panel, we do not use anymore the grid and the conversion factor is just one renewable. So our energy performance is now delivered energy, which is still 1 kWh, multiplied by the conversion factor, which is 1 kWh renewable energy. Our building is running on renewable energy. But what happens if somebody turns the light off? The building is still fed by the PV panel, so 1 kWh renewable is still coming in through the assessment boundary and it has to be exported again through the assessment boundary to the grid. So if we calculate the energy performance in this condition, we know for sure that there is 1 kWh renewable energy delivered by the PV panel, but we have to deduct the value of the exported energy. The physical amount of exported electricity is for sure 1 kWh. But which is the correct weighting factor for this exported electricity? The first possible point of view is rating the exported electricity according to what has been used to produce it. So in this case, this exported electricity is actually the PV electricity coming out again. So in this case, we will rate this electricity as one renewable. If we do the calculation in this way, this PV electricity comes in and then goes out, so the net effect on our building is 0. It cancels out. So we express this by saying the exported energy doesn't contribute to the energy performance of the building because it's counted both as coming in and coming out with the same weighting. This is also called option A, and this is indicated by a value of the K exported equal to 0. A second way of rating the exported electricity is taking into account primary energy avoided by grid generators. So that is, when exporting 1 kWh to the grid, we are avoiding the grid using 2.5 kWh non-renewable. So if we calculate the energy performance in this condition, we still have our PV electricity delivered to the building, so 1 kWh times 1 renewable, but then we have to deduct the 1 kWh physical electricity exported to the grid multiplied by the conversion factor, which is now 2.5 non-renewable. It is evident that in this case this doesn't cancel, and so we express this fact by saying that the exported energy is part of the energy performance of the building. This is also called option B, and it is selected by using a value of K exported equal 1. And this has effects like cross compensation between energy carriers, because this minus 2.5 non-renewable, because of this exported electricity, may compensate it, for example, the use of 2.5 kilowatt hours of gas, because the energy performance is only one equation where it will sum up all the possible contribution of your energy carriers. So we can summarize by saying that when you are exporting 1 kilowatt hour electricity, you have two possible point of views: using the cost of generating the exported electricity, or using the effect on the grid of the exported electricity. Both these evaluations are possible and correct, but you have to select which one in calculating the energy performance of your building. This is controlled by the K exported factor, and if you need more information, please see EN 52000-1, and don't forget to have a look at the technical report where these issues are illustrated in more details. Thank you. This video has been prepared by EPB Center team under contract with the European Commission. The information and views set out in this video are those of the authors and do not necessarily reflect the official opinion of the European Commission.